Hey everyone, and welcome back to the channel. Today, we're diving deep into one of the most fundamental concepts in programming, loops. Specifically, we're going to master loops in C++. If you've ever wondered how programmers make computers do the same task over and over again without writing the same code 1,000 times, well, loops are the magic behind it. So, what exactly is a loop? Imagine you need to print the numbers from 1 to 100 on the screen. You could write a count statement 100 times, but that would be incredibly tedious, right? A loop lets you write the instruction to print a number just once and then tell the computer, hey, repeat this action 100 times. It's all about efficiency and automation. In programming, we call this process iteration. Loops allow us to execute a block of code repeatedly as long as a certain condition is true. C++ gives us several types of loops to handle different situations. The main ones we'll cover are the for loop, the while loop, and the do-while loop. Each has its own strengths, and knowing when to use each one is key to becoming a proficient C++ developer. Let's start with the most common one, the for loop. The for loop is perfect when you know exactly how many times you want to repeat a task. Think back to our example of printing numbers from 1 to 100. We know we need to do it 100 times. The syntax of a for loop might look a bit intimidating at first, but it's really straightforward once you break it down. It consists of 3 parts, all neatly packed inside parentheses. The first part is the initialization. This is where you declare and initialize a counter variable. For example, int I equals 1. This sets up our starting point. We're telling the loop, let's start counting at 1. The second part is the condition. This is the test that C++ performs before each iteration. As long as this condition is true, the loop will continue to run. For our example, we'd write I less than equals 100. This means, keep going as long as our counter I is less than or equal to 100. The third and final part is the update. This is what happens after each time the code inside the loop runs. Usually, we increment our counter. We'd write I++, which is shorthand for I equals I plus 1. This tells the loop, after you finish an iteration, add 1 to our counter before you check the condition again. So, putting it all together, the code would look like this. For int I equals 1, I less than equals 100. I plus count less than I less than end all. Let's trace it. First, I is set to 1. The condition 1 less than equals 100 is true, so the code inside the curly braces runs, and it prints 1. Then, the update happens, and I becomes 2. The condition to less than equals 100 is still true, so it prints 2. This process repeats all the way up to 100. When I is 100, it prints 100, then I becomes 101. Now, the condition 101 less than equals 100 is false, and the loop terminates. The program then continues with whatever code comes after the loop. Pretty neat, right? The for loop is your go-to tool for controlled, counted repetitions. Next up, let's talk about the while loop. A while loop is a bit different. It is best used when you don't know in advance how many times you need to loop. Instead, you want the loop to continue as long as a certain condition remains true. It's a condition-controlled loop. The syntax for a while loop is simpler than a for loop. It's just the keyword while followed by a condition in parentheses. For example, while condition, code to execute. The code block inside the curly braces will run over and over again as long as the condition evaluates to true. Let's imagine a simple game where a user has to guess a secret number. The loop should continue until they guess correctly. We don't know if it'll take them 1 guess or 50 guesses. This is a perfect scenario for a while loop. Let's set it up. We could have a secret number, say int secret number equals 7. We also need a variable to store the user's guess, like int userGuess. Our loop should continue as long as the user's guess is not equal to the secret number. So the condition would be while userGuess equals secret number. Inside the loop, we would prompt the user to enter their guess and then read their input. But wait, there's a potential problem here. If the loop keeps running as long as the guess is wrong, we need to make sure there's a way to change the guess inside the loop. If we don't, and the initial condition is true, we could create an infinite loop, where the condition never becomes false and the program gets stuck forever. So, inside our while loop, we'd have something like count less than guess the number. Sin greater than user guess. This way, with each iteration, the user provides a new value for user guess. Once they enter 7, the condition user guess equals secret number becomes false, and the loop will end. After the loop, you could print a congratulations message. The while loop gives you flexibility when the number of iterations is uncertain and depends on some changing state or user input. Now, let's move on to the third type of loop, the do-while loop. This one is a close cousin of the while loop, but with one crucial difference. A do-while loop always executes the code block at least once before it even checks the condition. Why would you need this? Think about a menu-driven program. You always want to show the menu to the user at least once, right? Then, based on their choice, you might decide whether to show it again. The do-while loop is perfect for this do first, ask later logic. The syntax looks like this: do a code to execute while condition. Notice the while and the condition are at the end, and there's a semicolon after the parenthesis. The program enters the do block, executes all the code inside, and only then does it check the while condition. If the condition is true, it jumps back to the top of the do block and runs it again. If it's false, it exits the loop. Let's use our number guessing game as an example again. With a while loop, we had to get the user's first guess before the loop started. With a do-while loop, we can handle it more elegantly. The code inside the do block would prompt the user and get their input. Then, the while condition at the end would check if their guess was correct. So it would look something like this: do count less than enter your guess. Sin greater than user guess, while user guess equals secret number. The first time through, the user is prompted to enter a guess, no questions asked. Then, the program checks if the guess is wrong. If it is, it loops back and asks again. If the guess is correct on the very first try, the condition user guess equals secret number is false, and the loop terminates after just one run. This structure is often cleaner for scenarios that require at least one initial action. So to recap, use a for loop when you know the number of iterations. Use a while loop when you need to loop based on a condition that is checked at the beginning of each iteration. And use a do while loop when you need to loop based on a condition, but you want to guarantee the loop runs at least once. Mastering these 3 loop structures will drastically improve your ability to write powerful and efficient C++ programs. They are the building blocks for so many algorithms, from processing data in arrays to creating interactive applications. Practice is key. Try creating your own simple programs using each type of loop. Make a for loop that prints all the even numbers up to 50. Create a while loop that simulates a countdown. Build a simple menu system with a do-while loop. The more you use them, the more natural they'll feel. That's all for our introduction to loops in C++. I hope this breakdown was clear and helpful. If you have any questions, feel free to drop them in the comments below. Hey everyone, and welcome back to the channel. Today, we're diving deep into a fundamental concept in C++ programming: repetition. How do we make our code do something over and over again without writing the same line 100 times? The answer is loops. We'll be looking at 2 of the most common and powerful loops, the for loop and the while loop. By the end of this video, you'll know exactly how to use them, when to use them, and what makes them different. So, grab your favorite drink, fire up your code editor, and let's get started. First up, let's talk about the for loop. The for loop is your best friend when you know exactly how many times you want to repeat an action. Think of it like a countdown or a count up. The syntax might look a little intimidating at first, but it's super logical. It has 3 parts, all separated by semicolons. First, the initialization. This is where you declare and set up your counter variable, usually I, for integer. You'll see something like int I equals 0. Second, the condition. This is the test that C++ performs before each loop. As long as this condition is true, the loop will keep running. For example, I less than 10. Third, the increment or decrement. This is what happens to your counter after each loop. Most often, you'll see I++, which just means add 1 to I. So, let's put it all together in a simple example. Imagine we want to print hello, C++, 5 times. Here's how you do it with a for loop. We'd write for int I equals 0, I5, I++. Inside the curly braces that follow, we put the code we want to repeat. Count less than hello, C++. Less than endl. Let's break it down. We start with I at 0. Is 0 less than 5? Yes, so we print hello, C++. Then, I++ runs, and I becomes 1. Is 1 less than 5? Yes, we print again. This continues until I becomes 5. Is 5 less than 5? No, it's not. The condition is now false, so the loop stops. Simple, right? You get exactly 5 printouts. This structure is perfect for iterating through arrays, processing a fixed number of inputs, or any task where the number of repetitions is known beforehand. Now, let's move on to the while loop. The while loop is a bit different. It has the go-to choice when you want a loop to continue as long as a certain condition is true, but you don't necessarily know how many times it will run. Think of it as saying, while this is true, keep doing this. The syntax is much simpler than a for loop. You just have the while keyword, followed by the condition in parentheses, for example, while condition. The code inside the curly braces will execute repeatedly as long as that condition evaluates to true. Let's look at an example. Suppose we want to write a program that keeps asking the user for a number until they enter the number 0. We do not know if they lines get it right on the first try or the 10th try. This is a perfect job for a while loop. First, we need a variable to store the user's input, let's say an user_input. We might initialize it to a non-zero value, like in user_input equals -1. Then we set up our loop, while user_input equals 0. Inside the loop, we prompt the user, count less than enter a number, or 0 to quit. And then we read their input, sin greater than user_input. This loop will continue asking for input forever until the user types 0. Once they do, the condition user_input equals 0 becomes false, and the program exits the loop. So, here's a crucial point about while loops. You have to make sure that something inside the loop can eventually make the condition false. In our last example, the user's input changed the value of user_input, which could eventually stop the loop. If you forget this step, you can accidentally create an infinite loop. For instance, if you write while true and have nothing inside to break out of it, your program will run forever, or at least until you manually stop it. This is a common bug for beginners, so always double-check that your while loop has a clear exit path. Let's compare them side by side to really solidify the difference. A for loop is considered a definite loop. You define the start, the end, and the step all in one line. It's clean, compact, and great for counting. For int I equals 1, I less than equals 10. I++ is the classic way to do something exactly 10 times. The while loop, on the other hand, is an indefinite loop. It's more flexible. It's perfect for situations driven by user input, file processing until you reach the end of the file, or waiting for a specific event to happen. You can actually write any for loop as a while loop. For example, our for loop that printed hello, C++. 5 times could be rewritten with a while loop like this, int I equals 0. While I less than 5 count less than hello, C++. Less than endl, I++. As you can see, the initialization, condition, and increment are all still there. They're just in different places. The for loop just bundles them neatly together. Let's try a slightly more complex challenge. How would we calculate the sum of numbers from 1 to 100? We could use either loop, but a for loop is arguably more natural here because we know we need to loop exactly 100 times. We'd start by declaring a variable to hold the sum, like in sum equals 0. Then, our for loop would be, for int I equals 1. I less than equals 100, I++. Inside the loop, we just add the current number I to our sum equals sum plus I. Or the shorthand sum plus equals I. After the loop finishes, our sum variable will hold the correct total. It's efficient and very easy to read. Now, what if we wanted to do the same task with a while loop? We'd set up our variables first, int sum equals 0, and int I equals 1. Then our while loop would check the condition, while I less than equals 100. Inside the loop, we do two things, add to the sum plus equals I. And then, crucially, increment our counter, I++. If you forget that I will always be 1, the condition I less than equals 100 feet will always be true, and you'll have an infinite loop. So again, while it works, you can see how the for loop is just a bit cleaner for this specific counting task. So, when you're writing your own code, how do you choose? Ask yourself this one simple question: do I know in advance how many times this loop needs to run? If the answer is yes, like iterating through the 12 months of the year or the 7 days of a week, a for loop is usually the best choice. It clearly communicates the definite nature of the loop to anyone reading your code. If the answer is no, like waiting for a user to type quit or reading data from a network connection until it closes, then a while loop is your hero. Its structure is built for handling these kinds of indeterminate situations. There is one more variation of the while loop worth mentioning: the do-while loop. It's very similar to a while loop, but with one key difference: the condition is checked at the asterisk and asterisk of the loop, not the beginning. This means a do-while loop is guaranteed to run at least once. The syntax looks like this: do a code to execute while condition. This is really useful for things like menu-driven programs. You want to display the menu options at least once, and then, based on the user's choice, you might display it again. Using a do-while loop ensures that first run happens automatically. So, let's recap what we've learned. Loops are essential tools in C++ for repeating tasks. The for loop is your structured, definite loop, perfect for when you know the number of iterations ahead of time. It neatly packages the initialization, condition, and increment all in one line. The while loop is your flexible, indefinite loop, ideal for when the number of iterations depends on a changing condition, like user input. And remember the do-while loop, a variation that guarantees the loop body runs at least one time. Mastering these loops will unlock a huge amount of power in your programming and allow you to solve much more complex problems efficiently. Practice using them. Try converting a for loop to a while loop and back again, and don't be afraid to experiment. The more you use them, the more intuitive they'll become. Thank you so much for watching. I hope this breakdown of for and while loops was helpful. If you have any questions, feel free to drop them in the comments below. And if you enjoyed this video and want to learn more about C++, don't forget to hit that like button and subscribe to the channel so you don't miss our future tutorials. Happy coding, and I'll see you in the next one. Hey everyone, and welcome back to the channel. Today, we're diving into a common but super useful C++ problem: how to count the occurrences of elements in a collection and then repeat them based on that count. This might sound simple, but it's a fantastic way to get comfortable with some core C++ features, especially data structures like maps. By the end of this video, you'll not only understand the logic, but also have a clean, efficient piece of code you can adapt for your own projects. So, grab your favorite code editor, and let's get started. First things first, what's our goal? Let's say we have a list of items, maybe numbers or strings, like 1, 2, 2, 3, 1, 1. We want our program to do two things. First, count how many times each unique number appears. In our example, 1 appears 3 times, 2 appears twice, and 3 appears once. Second, we want to use these counts to generate a new sequence. For instance, we might want to repeat each number according to its count, creating a new list. This is a fundamental pattern you'll see in data processing, frequency analysis, and even in some algorithm challenges. To tackle this in C++, we need a way to store our initial data. A std vector is perfect for this. It's a dynamic array, which means it's flexible and easy to work with. Let's declare one. We'll start by including the necessary headers: iostream for printing to the console, vector for our list, and map for our counting mechanism. Inside our main function, we can create a vector of integers. Let's call it numbers, and initialize it with our example data: 1, 2, 2, 3, 1, 1. Simple enough, right? Now we have our input data ready to go. The real magic happens in the counting phase. How do we efficiently count each element? We could use nested loops, but that would be slow, especially for large data sets. A much better approach is to use ASTD, map. A map is a powerful data structure that stores key-value pairs. In our case, the keys will be the numbers from our vector, and the values will be their counts. So, we'll have a key 1 with a value 3, a key 2 with a value 2, and so on. Let's declare a map. We'll call it frequency map. The type will be std, map int greater than, meaning it maps an integer key to an integer value. Now, we need to iterate through our numbers vector and populate this map. We can use a range-based for loop, which makes the code super clean. The loop will look something like this for int num, numbers. For each number num in our vector, we want to increment its count in the frequency map. The beautiful thing about std map is how easy this is. We can just write frequency map num++. If the number num is not yet a key in the map, C++ will automatically create it and initialize its value to 0 before incrementing it. If it already exists, it will just increment the current value. After this loop finishes, our frequency map will hold the exact counts of every unique number in our original vector. Let's pause and check our work. It is always a good practice to print out intermediate results to make sure everything is working as expected. We can write another loop to iterate through our frequency map and print each key value pair. The loop would look like for const auto and pair, frequency map. Inside the loop, we can print pair. First, which is the number, and pair, second, which is its count. When we run this, we should see output like 1, 3, 2, 2, 3, 1. Perfect, our counting logic is solid. Now for the second part of our task, repeating the elements based on their counts. Let's say we want to create a new vector that contains the repeated elements. We'll call this new vector repeated numbers. We can iterate through our frequency map again, just like we did for printing. For each key value pair, the key is the number we want to repeat, and the value is how many times to repeat it. So, we can use a nested loop. The outer loop iterates through the map. The inner loop will run count times, where count is the value from the map. Inside this inner loop, we simply push _ back the key the number into our repeated numbers vector. Let's walk through it. The first pair in our map is 1 with a count of 3. Our inner loop will run 3 times, and each time it will add the number 1 to repeated numbers. So, our new vector will start with 1, 1, 1. The next pair is 2 with a count of 2. The inner loop runs twice, adding 2 each time. Our vector now becomes 1, 1, 1, 2, 2. Finally, we have 3 with a count of 1. The inner loop runs once, adding 3. The final repeated numbers vector will be 1, 1, 1, 2, 2, 3. Notice that the order depends on how the map stores its keys. std map automatically sorts its keys, so our output will be ordered by the numbers themselves, not their original order of appearance. If you need to preserve the original order, you might consider using std, vector of pairs, or a different approach. But for now, let's stick with the map. We've populated our repeated numbers vector. The last step is to print it out to see the final result. We can use another simple range-based for loop to iterate through repeated numbers and print each element to the console. And there you have it, a complete program that counts element frequencies and then uses those frequencies to generate a new, repeated sequence. Let's recap the entire process from start to finish. We started by including the necessary headers, iostream, vector, and map. We defined our input data in std, vector int greater than. Then, we created a std, map int greater than to store the frequency of each number. We used a clean range-based for loop to iterate through the input vector and populate the map, using the ++ operator to increment the counts. After verifying the counts were correct, we created a second vector, repeated numbers. We then iterated through our frequency map. For each number count pair, we used a nested loop to add the number to our repeated numbers vector the specified number of times. Finally, we printed the contents of the final vector to show the result. This is a really flexible pattern. You can easily adapt this code to work with other data types like std, string. Just change the vector and map types from int to std as string. The logic remains exactly the same. For example, if you have a vector of strings like apple, orange, apple, the map would store apple 2, orange 1. The principle is universal. This approach is also quite efficient. Iterating through the initial vector of size n takes linear time, or O(n). Inserting or accessing elements in a map takes logarithmic time, O log k, where k is the number of unique elements. So, the total time for counting is roughly O unlog k. Then, Generating the new list also takes on time in total because we are pushing back in elements in the end. This is much better than a naive OA solution using nested loops on the original vector. So there you have it, a complete walkthrough of counting and repeating elements in C++. I hope this tutorial was clear and helpful. This fundamental technique of using a map for frequency counting is something you lines use time and time again in your C++ journey. Try experimenting with this code, change the input data, use different data types, and see what happens. The best way to learn is by doing. If you found this video valuable, please hit that like button, and if you haven't already, consider subscribing for more C++ tutorials and coding tips. Let me know in the comments if you have any questions or what topic you'd like to see covered next. Thanks for watching, and happy coding!